So, this one is a new lesson for Chapter 4, and odd and even symmetry is the topic du jour, but that's kind of misleading because there's a whole lot of little other things that we have to teach you at the same time. I would like you to ponder the graph of y equals x squared. Everybody graph that briefly. You always know.
It's not on the board.
Thank you. Pausing for a moment. Got the tech issue fixed, and there's y equals x squared. Now, you probably just knew that one, didn't you? But do you get every now and then, like on the test, you were asked to graph something like y equals the square root of x minus 4, and if you were like, well, I never graphed that, well, then you probably get it wrong. Because on the test, we had you take a problem like that, and then find its inverse, and then find the domain and range of the inverse. So why would you ever need to graph this?
Because if you just find the inverse and you graph it, you'll end up with a parabola.
If you find the inverse and you just try to get the domain and range from that, it'll be wrong. And that's what a lot of you did. I warned you about this about 23 times. You got to start with the domain and range of the original one and reverse them. Kept telling you that over and over and over. So would you please just sketch this quickly? So would you agree that it kind of looks like that? Now what if you don't know what the square root looks like? Well, you're supposed to. And what if you don't remember even so, even though you're supposed to? Well, could you have made an XY chart?
Yeah.
Of course you could. And you could find out what anything looks like. So that brings up the topic of, well, what functions should we really already kind of know? Like, which one should we have memorized? Well, this is one of them. Square root's one of them. And now we decided to make a list of the top 10 functions that you ought to know. And we made a worksheet for it. And it's sitting there in Schoology today. The worksheet is called Top 10 Functions You Should Know. And I would like you to put in -2, -1, 0, 1, and 2 as your standard starting points. But do you get that those would be dumb on this function? Because -2 wouldn't work. Would any of them work? No, none of those would work. They would all give you no answer. You'd have to start here once you sketch the thing and you kind of know what it looks like. Then you can say, oh, I guess 4 could be put in, and so could 5 could be put in. You know, 5 minus 4 is square root of 1, and that would work. And all right, so this is what you should usually do on a normal function. But if the function's been moved, they aren't going to work anymore. But on the top 10 sheet, they're all normal ones. They haven't been moved a bit. I'd like you to open that sheet right now and tell me the first function that you see. It's called top 10. I know you were in something else right now, but stop and go and find the worksheet that I posted called Top 10 Functions. Got it?
First function is y equals x.
And I know you might be like, that is so easy. But do you get we even needed it in our last chapter? Because it was the line that you reflected across. You know what I mean? So we needed to know that one. And one more thing. Underneath it, I would like you to put the identity. It makes me think of like, there's movies where people, Ocean's 11. Have you guys seen that one? Good movie. And one of the guys is the thief. And one of the guys is the con man, basically. And one of the guys is, they all have their different roles, okay? Well, did you know that out of these 10 functions, they all have a name? That one's called the identity function. So I'd write it right there on your worksheet. It's called the identity. And if, I know this one's like super easy, but if you put in -2, you get -2. If you put in -1, you get -1. If you put in 0, you get 0. If you put in 1, you get 1. If you put in 2, you get 2. The number keeps its identity, hence the name, the identity function. All right, what's the next one they ask us to do? Can you tell me again?
X squared.
X squared. And that one's got a name too. It's the parabola.
That's the square.
And then there's another one, which is y equals x to the third. And I bet you probably already know the name, but I don't know. Maybe you don't. Cubic. It's called the cubic. The parabola, the cubic. How about well, they don't do x to the fourth. Did you know that from then on, all of them just start repeating other functions? Like if it's x to the fourth, it looks a lot like x squared. If it's x to the fifth, it looks like a lot like x to the third.
Well, after
Go x to the sixth, it looks like a lot like x squared again. Okay, they get narrower, but other than that, they're just parabolas over and over. And okay, so then what other important ones? Could you read me the next one, Nico?
square root of x equals what?
Square root of x, also known, aka
Square.
Root,
Root.
two squared.
Yeah. He's gonna bring.
the square root.
Oh. We were both right.
And you could easily call it the root. I like that too. All right. Now, to give you the rest of them would be kind of slow and clunky and takes a long lesson. So there's a key for the top 10 functions. We're mostly just reminding you, hey, you guys, you need to know these 10 functions. Like from now on, if I say 1 over x squared, you might be like, I don't know what that looks like. But we're reminding you can make an XY chart and you can stick in some numbers and you can figure out what it looks like. I'll tell you what it looks like. It looks like this.
Whoa.
I call it the volcano. And 1 over x. Do you guys remember that one?
Yeah.
Strikingly similar to the volcano, except, see, on the other one it was squared, so you could never get a negative answer out, you know, if the x is getting squared. So then this part gets flipped up to here, and that's why they look so similar, because one of them's very similar, except it gets squared, so, all right. All right, so they're related, of course. The only two that are on here that are difficult is, I'm just going to give you this hint. Y equals e to the x. You better at least know what e is. You probably learned it last year in the context of natural log. Do you even remember taking logs last year? Y equals log base 2 of x or something like that. You had logs last year. I know you did. Dig deep. Did you have logs for like a week at least? Maybe even 2 weeks?
2 weeks, but.
I think you had them. But anyways, either way, we will act like you didn't have them, but we will go extremely fast because we know that you actually did have them. All right, so anyway, do you remember that if you had a log base e, that's called ln of x? Ooh, really stretching you. Maybe you never saw that one. It's possible. But this all revolves around e. So I got to at least today tell you what e is. E is 2.718.
Huh?
Yep. That's just about as good a description as when some teacher at some point told you that pi is 3.14. Was that really, really accurate? No. But is it an estimate? Yeah, and it's going to be good enough for now. E is 2.718, and it goes on forever, just like pi does. I'm not going to make you memorize it.
Why is it less cool than pi? Because I feel like pi is not cool.
I think, I agree that pi is cool, but less cool? Not really. E is just less understood because you have to get a lot further than just circles. And almost everybody gets circles and then they therefore get exposed to pi. But you guys are finally getting up into the upper echelons of math where like it'll become a big deal to use E a lot and then you'll understand it a lot better. For right now, I'm just going to tell you that would you agree you can graph it if you know that it's 2.718? Let me prove it to you. Y equals 2.718 to the 0 power. What's that equal to? 1. Boom. I know a point. If x is 0, y is 1. So 0, comma 1. It's an xy chart. You can graph anything with an xy chart, even weird things like e to the x. If I stick in 0, I get 1. What if I stick in 1? I get 2.718. Yikes, or modern art. There. All right, how about if I put in 2? I don't really know what 2.718 squared is. Would you agree it's about 3 squared? Little less? 3 squared's 9, so maybe 8-ish? Like 8 point something? Not sure, but that's okay. Do you get that I'm not going to care as long as you make it bigger than 8?
Yes.
Good. Not going to expect you to be exactly right. Okay. So In fact, I'd even say if you think of this as 3, then you could think of this as 9, but it's a little less than 9. So maybe like 8
It's 7.4.
Okay, good enough. And my point, and you must have looked it up, right? Did you memorize it? Oh, yeah, on the calculator, yeah. So that's cool. I'm trying to say on your graph, I don't need to know exactly what it is. I just need to know that you knew it was less than 9. In fact, it was even less than 8. Thank you. All right, moving on. I hope that now I could give you a weird function and you wouldn't be just like, but you never taught us that one before. 1 over x to the third. I haven't ever taught you this before. Do you have confidence that you could figure out what it looks like?
Yes.
Yeah. XY chart. You'd put in -2, -1, 0, 1, and 2. That's my best advice, and then go from there. Because they almost always are centered around the origin. Because, oh, one more thing. If you ever make the bottom 0, you have found an asymptote?
Yes.
Because if you make the bottom 0, it can't exist, so that's an asymptote line. All right? All right, enough about those functions, those 10 functions. That is due on Thursday. Whew. Next, I got to get back to the meat of this lesson. When we graphed this, it started us on this journey. Right there. And I graphed that because that is the ultimate even function. Would you agree that it has y-axis symmetry?
Yes.
So even, I would make this as an example for yourself that that's the ultimate even function. Are there other even functions? Of course. But there's a lot less odd functions. And here's the ultimate odd function, because it's the simplest one. And do you remember the kinds of symmetry? That doesn't have y-axis, and it doesn't have x-axis. It has what kind of symmetry? Origin, very good. Origin, odd. Coincidence? Yes, but it worked out pretty nice. Okay, so origin. Those functions that have origin symmetry are odd functions. And why won't we ever have this kind of symmetry for our functions? This is not a function. Doesn't pass a vertical line test. Good. So we won't have to worry about that kind. They don't have a name because they're not functions. We're only dealing with functions right now. Okay. So if I give you a function and I show you a picture, you should be able to say, does that have even symmetry? No. Does that have odd symmetry? Yes, it's the same as origin symmetry. So yes, it has odd. It's an odd function. And it has origin symmetry. Okay. But what if I give you an equation? How do I tell by just looking at the equation, not looking at the graph? How do I tell if this thing is an odd function or an even function? I'm going to pause for a second while you ponder that. How could I tell if this is odd or even? Kent, I'm going to ask you to go to the next page of the notes. Wait. The next page of the notes is not what I was thinking it was going to be. All right, I'm going to go back to this and say y equals x to the third. What was that equation I just gave you? Plus 3x squared? Okay, all right. I will show you right now, since I brought it up. There is a slide later that's going to tell you this, but that's okay. I'm going to tell you now. This is our function. It's a function. You know how I know it's a function? Because it's only one y. Y equals this. Done. If there was a chance I could solve it for 2 y's, then it wouldn't be a function. But this is a function. The question isn't, is it a function? The question is it an odd function? It's got an x to the third in it. Just because it has an x squared in it doesn't prevent it from being odd. Okay, here's how you tell. Please copy this down. And then above it, write this rule. F of negative x needs to equal negative f of x. That's the odd rule. The even rule is if you put in negative x, seems like you're going to be putting a lot of negative x's into things. Yes, you are. For the next week or so, till this unit is done, you'll be sticking in negative x and seeing what happens. If it comes out to negative f of x, you found yourself an odd function. If it comes out to regular f of x, then you've got an even function. I know you don't know what that means quite yet, but I'm going to show you. All right. Have you got this copied down yet? The slow neck rolls is making me nervous. All right. Just stay with me. Now we're going to put f of negative x. So what are we doing? We're sticking in negative x. You can do that. I just taught you to do that last unit. Coincidence? No, this time. Not coincidence. We on purpose made you evaluate functions with weird things. We've had you put x plus h in there a lot, you know? Had to put in weird things into your function, so you're going to put in negative x into your function. And by now you've been trained that these parentheses are critical. Because if you don't have them, the answer will be different. Without these parentheses, this would have been 3 minus x squared, which is totally different than 3 times negative x to the power of 2. All right, so here's what this simplifies to. F of negative x. That seems like it stayed the same for a while. Yep. And this is negative x to the third minus, no, it's not minus, Mr. Server. Why is that not going to be a minus 3x squared?
It's in parentheses.
Something squaring like this, the negative goes away. Plus 3x. Now I ask you, did this come out exactly the same as it was in the first place? No, it did not. It did not come out exactly the same as it did in the first place. Because of this negative right there, it did not come out exactly the same as it did in the first place. Now, did it come out where there's a negative in the front, like this? Well, kind of, but the way you really need to tell is you need to factor out a negative 1 at this point. Everybody please copy this line. Negative 1 gets factored out. Man, it seems like factoring is seriously in every lesson or every other lesson. You got more factoring. That's why I needed you to learn that stuff, because we get into weirder and weirder factoring. Now we're factoring out a negative 1. And we get x to the third minus 3x squared. Is this f of x? Nope. Then this is not even and it's not odd, so it's neither. It's neither nor. Okay, I'm going to give you another one that's super simple, but you got to do it yourself. Would you agree that y equals 6x squared? If you think about what it looks like, it's probably going to be an even function. Okay, would you prove it, please? Act like it's a test, and you had to prove it. You can't just sketch it and say, look, it looks even to me. That's not proof. What's the proof? If you put in negative x, this should come out to regular f of x. That's the even rule. The odd rule has negatives on both sides. That's odd. Here's the odd rule. Notice they start identical. You put in negative x either way. It's just that if it's an odd function, you'll have a negative in front of the function. You'll be able to factor out a negative 1. I like to put a negative 1 there. I think that's extra smart. Okay, now I've got f of x. All I've done so far is change y into f of x, which should be super easy. Then you should be able to go f of negative x. That's me sticking in a negative x to try to prove something. If you're not following this along, you're saying, I don't care to learn that, Mr. Server. Because if you're just watching me, you're going to remember 10%. 10% of this screen is maybe these two numbers right there. You'll be like, well, I know there was a 6x involved. Okay, if you're actually copying this with me, you have a chance of understanding it. Okay, so look, would you agree that at the beginning, this was our function, and now it's back again? Even though we stuck in a negative x, we got the original function back. So here's how you end. So when I put in f of negative x, I got, and can't I replace this with f of x? Isn't this equal to f of x? Yup, look at that. The odd rule. No, even rule. I proved it's even. And that's how you prove something's even. You can't just look at the picture and maybe even visualize it and go, yeah, that's going to be odd, or that's going to be even. You have to prove it. So now, without my help, prove that f of x equals negative x to the third is actually odd. Prove that it's odd. The odd rule should be what you get at the end. At the very bottom, you should have f of negative x is equal to negative 1 times f of x. Remember that factoring out the negative 1 thing at the end? All right, I'll pause for a second and give this one a try. Okay, let's see if you figured it out. So first off, I have to stick in negative x. If you didn't get that far, sad. You should know to stick in negative x. Now I'm going to put the x in parentheses. Notice just the x goes in parentheses, not the negative in front of the x, just the x. That'll help you whenever you're sticking things into equations if you replace just the variable with an empty parenthesis. Now I'm going to put in a negative x there. Now I'm smart enough to know that this would come out negative, but then there's another negative there. What does that make it? Positive. Okay, so now I get f of negative x equals positive x to the third. Now this is critical. You might look at this and think you could stop right there. You cannot. You know why? Because you haven't proved that f of negative x came out to negative 1 times f of x. Remember me saying you needed to factor out a negative? So I'm going to factor out a negative from that, and I'd have negative x to the third. Now, was this really f of x? Yeah, look at that. It was. So I can replace that with f of x. And I've got my ideal statement that f of negative x came out to negative 1 times f of x. Notice I had to factor out the negative 1 to make it work at the end. All right. That's the main thing for today. Now I got a bunch of other little things. I'll come back to the proving things in a minute. But increasing and decreasing. Would you agree that in this little zone right here, as you read from left to right, that is increasing? That makes sense? It's increasing. It's going up as you read from left to right. Okay, so how do I say the answer then? Well, this is negative 1, 2, 3, 4, 5, 6, negative 6, comma, negative 1. And this spot right here, we're going to say that that's negative 1, comma 3. You say it by saying the x values, negative 6 to negative 1. That's like saying from here, that's where negative 6 is, to here, that's where negative 1 is. That's where it was increasing. This next little part, I hope we recognize the teacher was trying to keep it flat right there. And so that is called constant. So it's constant from negative 1, which is what was right there, to about, I think that's about 4. Would you agree? Then it was constant from negative 1 to 4. These are intervals, not points. And it was decreasing since, let's just name that point. Let's say that that was 4 comma 3. Then it's decreasing from 4 to infinity. And I totally get some kids think it's decreasing to negative infinity, but that misses the point. It's decreasing from here to, where's another line here where it stops decreasing? All the way over at infinity. These are x values. I know the y value goes to negative infinity, that isn't the question. These are always x values in your interval. This is a point right here, that's different. So this went from 4 to infinity. It was decreasing. Yes?
Do you ever need to use brackets for any of this?
Good question. I get how you could very easily argue that 4 comma infinity should be in brackets, and I wouldn't even mark it wrong. But I'm telling you that the Schoology quiz and most books just use parentheses. The argument would be, is it still increasing at 4? That's a really hard argument to make. Is it increasing there? How can you in one point be increasing? At a point. You're not really increasing or decreasing. It's just a spot. So that's why it's parentheses. Okay. 4 to infinity was the answer there. Just to make sure you got that, I'm going to just give you a point here. We're going to say that the highest spot there is at negative 4 comma 3. And we're going to give you we're going to say that it hits its lowest right there, which is going to be at negative 2 comma 1/2. Then in the interval between those 2 points, what's it doing? Decreasing on the interval from, please don't say the 2 points. Decreasing from where to where? Negative 4 to negative 2. I almost wish it didn't have parentheses because it looks like a point when you make it have parentheses, but technically it needs parentheses. Negative 4 to negative 2 is the interval over which it's decreasing. All right, the next thing I have to teach you is about high spots and low spots. Imagine for a moment that we had a leg wrestling competition in here. My daughter was really good at that. It was kind of, if you're ever in a mixed group of boys and girls and you want to like have some kind of a contest, the arm wrestling contest might be tilted in a particular direction, but leg wrestling, it can actually go either way. And so let's imagine for a moment that we have a leg wrestling competition in here, which is kind of like arm wrestling. It's just that you both put a leg up and you try to push the other person's leg over. Okay, so anyway, you're going to be lying on the ground. So imagine we do that and Nick wins. Congratulations. I think your height and the physics of it, it makes sense to me. He probably wins. So let's say he wins. Does that mean he's the strongest kid in the world?
Absolutely.
Does it mean he's the strongest kid in the room?
Most
If he wins that contest, at least when it comes to legs, he would be the local maximum. But does that mean he's the strongest kid in the whole world? It's actually unknown.
Exactly.
We don't know.
You can't say no.
He could be the strongest leg wrestling kid in the world. It's probably not likely. It'd probably be some wrestler from Yugoslavia or something. They're really good at wrestling. Okay, so there's probably some kid that would beat you. So, moral of the story. This spot, it's locally a maximum, but it's not the absolute max. In fact, we know it's not because there's a spot over here that's higher. That's called a local max. And this one's called an absolute max. But wait, isn't it also a local max? Yes, it is. That confuses people because they're like, no, it's the absolute max. It'd be like saying, no, Nick isn't locally the strongest kid. Well, yeah, he's also the locally the strongest kid, and let's say he's also the strongest kid in the world. You can be both. So this would be a local max, and it would be an absolute max. How about min? This one has a local min. I like to think of it as a place that water would collect. Would you agree that if this was made out of metal and it rained outside, water would collect there? Why does that matter? Because I'm going to give you an example in a moment where a lot of people would have said it was a local minimum, but water wouldn't collect there.
Sorry, not sorry.
Yes?
I just wanted to say, would the absolute max be infinity?
No. Oh, wait a minute. Down here. I think you might have gotten me. That's what you're referring to, isn't it?
Yeah.
This would keep going up, and it would have been more obvious if they would have continued that line. But yes, we have to assume that's going to keep going up, and you're right. That has been dethroned. It's not the absolute max anymore because this would keep going up, and therefore it's a local max, but not the absolute max. Nice catch. That's a good catch. It's so easy to miss. Okay, yes.
So since these are points, do we have to like do the brackets?
You just list the point.
Oh, okay.
Just list the point as a point. All right, so the local max is there. All right, let's just look at one more, and it'll be less confusing because I'll make it clearly go down in both sides. Then does this have a local minimum? Stare at the local minimum. Are you staring there?
Yes.
That is the local minimum. All right, would you agree that this is the absolute maximum? Would you agree that this is also the local maximum? And how about this spot here? Is that a locally a maximum? Yes, it's a high spot around where it is. We found out in Florida that my sister's condo was a local minimum. Know why? Because she has a condo in Florida. What do you think happened? Flooded. So she went in there and the walls were just like covered with mold going up the side of the walls because water had washed in underneath the door on both sides, and her house had been just sitting in nasty. The water isn't clean, you know. You think of clean water maybe. No, this is like nasty, muddy, dirty, you know, like all kinds of bugs and things in the water. And then it just sits there in the hot sun, and those condos didn't have any air conditioning because it turns off because, you know, giant storm, of course the power's going to turn off. And so it just baked, and now it's completely totaled. Do you get if she would have been at a local maximum, as in the high spot around her? No damage. So, remember, if I was telling you, actually it was in a different class, but in the context of x to the negative 2, these want to move down to the basement, and that makes them happy down there. The people that were on the bottom were definitely like numbers with negative exponents. They wish they were up here because the people on the lower level condos are totaled and the people with the upper level condos are fine. So that's one of the reasons that higher level condos go for more money. So not saying that you should always want the higher level condos, because if you've got a bad knee, bad hip, you got to walk up all the stairs all the time, maybe you factor that in, but there's a reason that every story you go up is about $10,000 more, because the higher you get, you also get a better view. Okay. I know it's a little random, but it did remind me of this. That's a low spot. It's where the water would collect, and that's what happened to my sister, is that her condo got torched. Other condos were okay. Not all of them. A lot of the lower level condos were totaled. Okay. Does this one have an absolute minimum? You can't say that's the low spot. Nope. It does not have a minimum. And that's different than saying negative infinity. I would get a kid saying the absolute minimum is negative infinity, but that is saying there's the low spot, and you can't identify where infinity is. So you have to say no, there's no local minimum. All right, so one last one. Does this, yes, have an absolute maximum? Nope. Because it goes up forever. Does this have an absolute minimum? Nope. Does it have a local maximum?
Yes.
Does it have a local minimum?
Yes.
Does it ever increase? Is there any zone over which this function increases? Yes, for sure. From here to here. And you'd say from negative infinity until 0, it was increasing. And let's give this spot a name right there. Let's say it's 3 comma 1. Then it decreased. Let's say this is at 0 comma 2. Then it decreased from 0 to 3. Do you get how that makes sense? Okay, and then when did it start increasing again? At 3. So it increased from 3 to infinity. It's because from there over, it was increasing. There now. I've taught you everything. That's a lot, I know, and I can't expect you to be perfect yet. But here's what I'd like you to do. I'd like you to start the Schoology quiz with me right now. And then that top 10 functions thing, that just due Thursday. It's laughably easy. You're just sticking numbers into the function, except for the last 2. So why don't you get the first several done on that today? And maybe we can work on that a little more tomorrow. So the top 10 functions, get it started. The Schoology quiz, get it done. Read me the first question of the Schoology quiz. I know it's a picture, but please call it up on your iPad so I can copy that picture. I know you have a question, but I want to get started on the homework first before I go back. All right, I see it. It generally looks like that. If I got it right, the left end's down, the right end's up. Okay, good. Now, this is a kind of weird multiple choice. You check all of them that apply. Okay, so the very first statement they said is this function is increasing. Actually, that's not true because it's sometimes decreasing. There are functions that are only increasing, and I want to give you one because it confuses people sometimes. Would you agree that that function was increasing? As you read from left to right, it still goes up. But people are like, but what about this spot? If I drew this correctly, there should not have ever been a spot where it was lower on both sides of that point. It just turns at that point. That's called an inflection point. So would water gather at that spot if it rained? No, water would not gather at that spot. And therefore, that is not a local minimum right there. Because on the x to the third function, it's always very slowly increasing. At a moment, in a way, you could say at that exact second it became constant, but only for like an instantaneous moment. But it never got lower, so there would never be water collecting, so that is not a local minimum. And this function was increasing. Back to this function that you were asked about, there's several check marks. I think there's 4 of them that you have to check. So don't just assume you're done if you found one thing that's true. There's quite a few things that are true about that function. Can anybody verify that it's 4? It might be 3. I'm not sure. Did you find... You think there's 3 things that are true about it, or 4?
5.
Oh, there's 5 things that are true about it. Okay, that's possible. My point is, don't be duped into thinking this is like multiple choice. I found the answer, I'm done. You got to look at each thing and decide if that's one of the right answers. Okay, cool. I think you got your Schoology quiz going, and now I got to get your test back to you. So that's all the lesson for today.